So in this video, I'm going to talk about pOH, pH, pKw, and Kw. And then to be specific, I'm going to solve some questions, but in a separate video, I'm going to solve a lot of questions on pH generally, both how you can actually apply calculator and how you can actually solve the questions offhand, right, without using calculator. Now, let's just go ahead and do this. Now, what is pH? We all know that uh, pH is actually negatively logarithm of what, of hydrogen ion, right? Hydrogen ion concentration. That's exactly what pH is. But one thing I want you guys to understand here is that pH, this P simply represents what? Power, or you simply say it is potential, power of hydrogen, or you simply say potential of hydrogen. And it's actually the same thing as what? As negative logarithm and concentration that you're seeing here, right? If you take a look at it very well, right? So that's exactly what it means. But power simply means you are basically talking about what? The strength of an acid. And in order for you to determine the strength of an acid, you look at the dissociation, let me simply say, the dissociative nature of what? Of that acid. That is how the acid can easily what? Donate hydrogen ion concentration to either water or any other solvent, right? Now let's just go ahead and do this. We have pH to be equals to negative logarithm of hydrogen ion concentration, and then we also have pOH to be equal negative logarithm of what? Of hydroxide ion concentration. pOH is mostly used for what? Freeze, actually, right? Now let's say we have a scenario whereby we have, let me just say, we have water molecule, right, that dissociate into what? Into hydrogen ion and also what? Hydroxide ion, as you can see in this case, right? Now if you take a look at this very well, if I'm going to write the equilibrium constant for this reaction, or let me simply call it the dissociation constant, which is actually what? Kd. The dissociation constant is going to be what? Concentration of what? Of hydrogen ion, right, multiplied by that of what? Of hydroxide ion, then divided by what? H2O. You look at it very well. Now, if I just go ahead and choose to cross multiply here, let's see what I'm going to have. Or basically, I can actually go ahead and solve it together. But in this case, this is basically the dissociation constant of what? Of water. Dissociation constant of what? Of water. And what does it mean? It shows that if I cross multiply here, I'm going to have Kd, right? Then multiply what? H2O, which is considered what? Of H2O equals to what? Consider what? Of hydrogen ion concentration. Then multiply what? OH minus, which is hydroxide ion concentration. But what I want you guys to understand is that this Kd is actually what? A constant, which is the dissociation constant of water, and at the same time water as well, the concentration of water is what? Is constant. Concentration of water is constant, and then at the same time concentration of this Kd, the value of Kd is actually what? Constant as well, right? Now let's go ahead and do this. Since both of them is actually constant, I can actually represent these two bad boy here as what? Kw. Because since I said they are constant, then I'm going to represent that as another constant, because we are actually referring to water, and Kw simply represents what? Water constant. Water constant equals to hydrogen ion concentration, then multiply what? Hydroxide ion concentration. So that's actually what it means. Now look at this very well. This is another expression I'm having here, and the expression is also very, very important. You have to take note of it. It is also very, very important. Now let's go ahead and do this. So since I'm having Kw to be equal, considering what? Of hydrogen ion, then multiply that of what? Of hydroxide ion concentration. Now look at what I'm going to have. I can actually take negative logarithm of what? Of both sides, right? So in that case, taking negative logarithm of what? Of both sides, that is minus log of what? Of both sides, negative logarithm of what? Of both sides, you can say log to base 10 of both sides. We are going to have this to be minus log Kw, right? Then this is going to be equal negative logarithm of what? Of hydrogen ion concentration, right, multiplied by that of what? Of hydroxide ion concentration. Now if I apply logarithm identity here, do you know what I'm going to have? You know, this actually negative logarithm of what? Of hydrogen ion concentration, then multiply with that of what? Of hydroxide ion concentration. If I go ahead and separate, what am I going to have in this case? Separating this, I'm going to have this what? With negative logarithm of what? Of Kw, right? This is going to be equal, here I'm having log A B, which is actually what? Log A plus log B. So I can have this what? Minus into brackets logarithm to base 10 of what? Of hydrogen ion concentration, then plus log of hydroxide ion concentration. Now, if you look at this, what am I going to do? I can actually use this negative to multiply of us through to open the bracket rather. I'm going to have this to be negative logarithm of kW. This is going to be equal negative logarithm of hydrogen ion concentration, right? Then plus, then look at what I'm going to do here. I'm going to have open the bracket a negative logarithm of hydroxide ion concentration. So that's exactly what I'm going to have now. Now, what I'm going to do is that if you recall, pH is actually was negative logarithm of hydrogen ion concentration, right? And then pOH is actually was negative logarithm of hydroxide ion concentration. So that shows that if I'm having negative logarithm of kW, you know, I've once said that negative logarithm of concentration actually indicates what? Power, right? So I'm going to have this word to be pKw in this case, because this negative logarithm actually indicates what? P. So I'm having pKw equals to negative logarithm of hydrogen ion concentration is actually what? Is actually the pH, right? So I'm going to have pH, then plus what again? I'm going to have this to be negative logarithm of hydroxide ion concentration, which is also what? pOH. Right, so that's what I'm having. This is another expression I want you guys to take note of, right? So you have to take note of that expression at the same time, because we are going to use it, right? Now let's go ahead again. So the next thing I'm going to do is that if you recall, we already know that concentration of hydrogen ion according to the pH scale is always 10 raised to the power minus 7, and that of hydroxide ion concentration is also what? 10 raised to the power minus 7, right? Now from here, if I put this inside this expression, let's see what I'm going to have. So I'm going to have kW to be equal 10 raised to the power minus 7, then multiply 10 raised to the power minus 7. So kW is simply 10 raised to the power minus 14. That's what we have. Then if I go ahead and put this here, that shows that if kW equals to 10 raised to the power minus 14, then we're going to have pKw to be equals to what? Minus log kW. That's exactly what you have. Then from there, you're going to have pKw to be equal negative logarithm of 10 raised to the power minus 14. And if I apply logarithm identity on this side, I'm going to have pKw to be equal minus into brackets, open the brackets, 14, then log 10 base 10, log 10 base 10. So this log 10 base 10 is actually what? Is actually 1. That shows that the final thing I'm going to have is actually what? pKw equals to negative multiply negative. That's going to what? 14. So that's what pKw is what? Is 14. Then let's just see the final expression I'm going to have. Right? Let's see the final expression I'm going to have here. So in that case, since we said pKw is equals to 14, if I come back here, what do you think I'm going to do here? If I come back to this case, so if you recall from this side, we're going to have pKw to be equal pH plus what? pOH. That's what we have. Then that shows that I'm going to have pH plus pOH to be equal to what? 14. So that's exactly what I'm going to have. Right, so this is another formula that you guys have to take note of. You have to take note of this formula as well. It's very, very important. You have to take note of this formula as well. It's also very, very important. Right, so this formula as well is also very, very important. It is important at the same time. So these three formulas, as well as this one that you're seeing here, is also very, very important. Right, so kW is actually what? 10 raised to the power minus 14, right? So we can actually have this one to be another one. Let's just say we react the experiment to be hydrogen ion concentration, the multiply what? Hydroxide ion concentration to be equal to 10 raised to the power minus 14. So this one as well is also very, very, very important. So when we are calculating, we are solving a question that is under strong acid and strong base. We can actually make some of these 5 formula. So another formula that I'm going to derive is actually not really common like that, right? It's not common, but you guys have to take note of it. It's also very, very important. Now I'm going to derive somewhat from this from the first formula, which actually was pH, pH equals to negative logarithm of hydrogen ion concentration. So that's what we have. So from there, if I take exponential of both sides actually, or let me simply bring this minus to this side, I'm going to have negative pH equals what? Log of what? Of hydrogen ion concentration. Right? So if I take exponential of both sides, this is going to eliminate this. So that shows that exponential raised to the power minus pH is actually what? 10 raised to the power minus pH. That's the value of exponential. Then this is going to be equals to what? Hydrogen ion concentration. So this formula as well is also very important. That is hydrogen ion concentration equals to 10 raised to the power minus pH. So you have to take note of that. It's very, very important at the same time. Right? So these 6 formulas is very, very important to calculate pOH, pH, and also what? pKw and kW. The first question we are having here says, the hydrogen ion concentration of a solution is 1.0 multiplied by 10 raised to the power minus 5. Calculate both the pH and the pOH of the solution. It's very, very simple. Now look at this. I'm not going to, you just have to take note of the trick I'm going to be using in this, while solving this question. You have to take note of it. It's very, very important. Now, the first thing that is that you are giving hydrogen ion concentration, right? That's what you are giving. Of the solution is actually 1.0 multiplied by 10 raised to the power minus 5 molar, right? And you are asked to calculate both the pH, you are asked to calculate for what? For the pH, right? And also what? The pOH of what? Of the solution. You don't need to stress yourself. It's very, very simple, right? Now look at what I'm going to do. You just have to record two formulas. The first formula is actually pH plus pOH equals what? 14. Now suppose you don't know the value of what? Of P, you don't know the value of what? Of pOH. Or simply let me just say you don't know the value of what? Of pH, and you are giving what? pOH. That means that you're going to have pH to be equal 14. Look at this, oh, then minus pOH. That's what we are going to, what you are going to have. Now don't forget that pH is equals to negative logarithm of hydrogen ion concentration, right? And at the same time, pOH as well is also equals to what? Negative logarithm of hydrogen ion concentration itself. Now come down and take a look at this. It's very, very simple, but I just want to bring out the formula. That's why you are actually spending time on it. Now look at this. We are giving hydrogen ion concentration here, right? So that shows that since pH is actually what? Negative logarithm of hydroxide ion concentration, that's why I can actually make pOH also the sort of formula, which is actually going to be what? 14 minus pH. But what is pH? pH is actually what? Negative logarithm of what? Hydrogen ion concentration. That shows that I'm going to have pOH to be equal 14. Look at this. Oh, negative, so multiply and negative is going to be what? Positive. I'm going to have plus log hydrogen ion concentration. So this formula is very, very important as well. Now let me just, what you're going to do is just what? To put in a value of what? Of hydrogen ion concentration here. You're going to get your pOH. It's very, very important. Then from there, you're going to have pOH to be equal 14 plus log 1.0 multiplied by 10 raised to the power minus 5, right? So that's what we have. Now from there, look at this. Without using a calculator, you can first eliminate this log. You are going to have pOH to be equal, you're going to have 14. Now look at this. You have log, this is going to be 1.0 times 10 is still 10 raised to the power minus 5. So if you bring down this minus 5, you're going to have minus 5 log 10 base 10. And log 10 base 10 is actually what? Is actually 1. So that's the answer that you have here is actually what? Is actually minus 5. And in that scenario, what you're going to have is going to be what? Is going to be pH is going to be equal 14 minus 5. That's exactly what you're going to have. Right? So 14 minus 5, they are going to have pOH to be equal. 14 minus 5 is going to give what? Is going to give you, I think that's actually 9. That's your pOH. Right? So if pOH is what? Is 9, that shows that pH is going to be equal to what? 14. Look at this. Oh, 14 plus 14 minus let me simply say minus 9 rather. Right? 14 minus 9 minus 9. And that is going to be equal to what? 5. In that scenario, pH is 5. Why pOH is what? Is 9. Now look at the question we have here. The question says what is the pH of 0.025 molar of hydrogen chloride solution? Now what I want you guys to understand here is that if you look at this question very well, we are already given that the pH, right? We are already given that we are asked to calculate for the pH actually, given that the concentration what of hydrochloric acid is actually what? 0.0235. So what you have to do in this case is actually to write what the let me just say the equation for the dilution of what? Of this hydrogen chloride. Now from that case, we're going to have hydrogen chloride, right? Is going to dissociate into what? Into H plus Cl minus, right? Now if you look at this equation, it is actually balanced. That shows that we're going to have 0.0235 most of this one that actually dissociates to produce 0.0235 of hydrogen ion and also 0.0235 of what? Of chlorine ion. So that's exactly what it's been. So since this equation is what? Is balanced, we can now go ahead and what? And make it of what? Of this hydrogen ion, because that's actually what you are going to need to find the value of what? Of the pH. Right? Now from there you can recall pH is actually given as what? pH of the solution is given as what? As negative logarithm of what? Of hydrogen ion concentration. Now if you look at this, this is going to be pH is going to be equal negative logarithm of what? Of 0.0235, because from this case it is actually this one that we are going to make use of, not chlorine ion or this hydrochloric acid. So from here, you're going to have this word to be pH equals to what? So let's simply press our calculator and see what we are going to have here. We're going to have this to negative logarithm of what? 0.0235. So this gives us 1.63, right? So this is approximately 1.63. That shows that this is the pH of the solution. Since it is low, since the pH is actually low, that should indicate that the acid is a what? Is a very strong acid, and that's why it is what? Hydrochloric acid. Now let's move to the next question. What is the pOH? In this case, look at this. We're not asked calculate for pH, we are asked calculate for pOH. That's what we are asked calculate for, of a 0.0235 or molar of hydrochloric acid. Remember that whenever hydrochloric acid is dissolved in water, it's going to dissociate into what? Into hydrogen ion and also what? Chlorine ion, right? Now from that case, if that's the case, that shows that we're going to have 0.235 of this hydrochloric acid that actually dissociates to produce 0.235 of what? Of hydrogen ion concentration. Now if that's the case, we're going to have, we can actually make what of pH, which is actually equal, let me simply say pH is actually plus pH plus pOH is equal 14. That's actually what we're going to be making. That's what we're going to use, right? Now, and in that scenario, we can actually make pOH sort of formula. And in that case, we're going to have pOH equals what? 14 minus pH. That's exactly what we're going to have. And if you recall, pH is actually equals to negative logarithm of what? Of hydrogen ion concentration. That's what we have pH to be. Now, if I put it here, I'm going to have pOH to be equal 14 plus, open a bracket, negative logarithm of what? Of hydrogen ion concentration, right? Then we're going to close the bracket. So we're going to have pOH to be equal 14. Then this is going to be, since we have minus, we should have minus here actually, not plus. So this is going to be minus actually. So multiply minus is going to give us plus log of what? Of hydrogen ion concentration. So you can actually make what of this formula. Instead of, don't bother to stress yourself. Just if you know this offhand, you can actually recall it and go ahead and apply it. You are going to get the answer. It's very, very simple. Now let's go ahead and solve it using the formula to see what we are going to have. So from there, since we are asked calculate for the pOH, we are asked calculate for pOH, and then we already recall that pOH is equal 14 plus log hydrogen ion concentration. That's what we have. So that shows that in this case, I'm going to have pOH to be equal 14 plus log. We're going to have this to be 0.0235. That's what we're going to have. Then we're going to have our pOH to be something. So let me simply press my calculator. So we're going to have 14 plus log 0.0235. Close the bracket. Let's see what we're going to have. We have this to be this 12.37. So that's the pOH. So if you know this formula, you can actually solve it without stressing yourself. You just press calculator. 14 plus log, you put the hydrogen concentration there, you get your pOH. It's very, very simple. So that's it. So let's move to another question. What is the pH of 6.50 multiplied by 10 raised to power minus 3 molar of KOH? We know that KOH is a base, right? And whenever KOH dissociates, it's going to dissociate into what? Into K plus, right? Plus OH minus. And from here, this is OH minus, which actually represents the properties of a base. Then from there, we are asked to calculate for the pH. So what formula can we use? You can actually make of pH equals to 14 plus log hydroxide ion concentration. It's very, very simple and direct. Then just plug in your OH here. Since you're already giving the concentration of the base of the concentration of the base to be 6.5. You can actually, from the equation you see that 1 mole of this actually dissociates to produce 1 mole of this, and also 1 mole of this. So that's that the concentration is going to be equal, and in that case, concentration of OH minus is going to be equal 6.50 multiplied by 10 raised to power minus 3. So that's what I'm going to plug in here. So I'm going to have pH equal 14 plus log. We're going to have 6.50 then exponential minus 3. So that's what I'm going to plug in here. Now let's press my calculator. I'm going to have this to be 14 plus log is going to be 6.5 then multiply by 10 raised power, we're going to have minus 3. That's what we're going to have. Then let's close bracket and see what we're going to have. So in that case, the pH of what of the solution is actually what 11.79. And from there, since the pH is actually what 11.79, that indicates what a basic pH, a basic solution actually, because the pH is actually very high. And in that case, it's a basic solution. That's why we are having it to be KOH. We confirm it that it is actually a basic solution because the pH is 11.79. So that's just it. Now let's go ahead and solve one more question. Now if you take a look at the question that we have here, the question says a solution with a hydrogen ion concentration of 1.00 multiplied by 10 raised to the power minus 7 is said to be neutral. Why? It's very simple. We already given the concentration of hydrogen ion from the question to be 1.00 multiplied by 10 raised to the power minus 7. That's the concentration of hydrogen ion. Then let's go ahead and calculate the pH. The pH is actually going to be equal to negative logarithm of hydrogen ion concentration, right? So that's what we have. Then from there, I'm going to have this to be pH to be equal negative logarithm of the constant of hydrogen is actually what? It's actually 1.00 multiplied by 10 raised to the power minus 7. So that's what we have. Then from there, this 1.00 is still the same as 1. Then that should I'm going to have pH to be equal negative logarithm of 10 raised to the power minus 7. And look at that, whenever we are talking about logarithm, we always take it to be base 10. So from there, if I apply the logarithm identity, that is, whenever I'm having log a raised to the power of m is equal to as writing m log log a. So in that case, this is my this is going to be my m, and this 10 is actually my a. So if I bring down the m according to this identity, I'm going to have pH to be equal negative. Now look at this, open a bracket minus 7, which is the power. You bring it down, they're going to have log 10 base 10, and log 10 base 10 is equals to is equals to 1, right? So that's so that everything here is 1. So in that case, I'm going to have pH to be equals to minus multiply by minus is actually plus. Then I'm going to have 7. So this is going to be 7. So the pH is 7. Now the pH of the solution is always 7. The pH of a neutral solution is always 7 according to the pH scale, which ranges from 0 to 7, then from 7 to 14. So this 7 indicates a neutral. So any solution with the pH of 7 is actually a neutral solution. So according to this question, the reason why the solution is a neutral is because the pH is 7, right? So any solution that has the pH of 7 is said to be a neutral solution. So that's just it about this video. So if you enjoyed this video, don't forget to like, share, and don't forget to subscribe at the same time. And also make sure you support us on our other social media handle, right? Like the Patreon account, the Facebook page. You can actually do it to check it out. I'm going to drop the link in the description box below. Thanks for watching.